So hi there, everybody, and thank you for arriving to digest some new trigonometric content on this truly trigonometric Thursday. We have a little dusting of snow, and it's starting to feel festive. It's the beginning of the 25 days of Christmas. Okay, I'm confused, but my kids have got their advent calendars going, so maybe you have an advent calendar at home and you have your little dose of chocolate every day. Anyway, enough about that. Not handy, but I'll have to get one for you soon. Yeah, go ahead. Yeah. All right, so the reciprocal trigonometric ratios. We're going to learn today 3 new trigonometric ratios. We've got SOHCAHTOA, and I'll teach you some mental tricks to remember secant, cosecant, and cotangent. All right, these are just reciprocals of the trigonometric ratios we already know. So if you know how to flip a fraction, you already know these. There, done, lesson done. That was very simple. So cosecant is the reciprocal of the sine ratio. Okay, so if you take sine and flip it over, so instead of sine is opposite over hypotenuse, you have cosecant is hypotenuse over opposite, then that's what it is. So that is cosecant, yes. You would just, if you want to calculate cosecant, you can take sine. So let's say we do sine 30 degrees, and then you'd put that in brackets. You'd get the output, and then raise it to the power -1. Because what happens if I raise that to the power -1? Oh, it just flips it. It just gives you the reciprocal of that number. So yeah, sine 30 to the -1 is going to be equal to what? 1 over sine 30. What's sine 30? Who can visualize the 30, 60, 90 triangle? 1/2. So what's cosecant 30? Yes. So cosecant theta equal to 2, because we take sine 30, which is 1/2, and flip it over. And that's it. And then, so what's my sweet trick to remember which one goes with which? Well, secant goes with cosine. Okay, so if you take cosine, you flip it over, then you get secant. So if we were looking at secant 30, just to review our special triangles, that would give us 1 over cosine 30, or I'm going to write that this way, cosine 30 degrees, but then I raise the result to the -1. Note that's not inverse cosine. That's not the way you write inverse cosine. That's I take the value of cosine 30 and raise it to the power -1. Inverse cosine would look like this. Cos inverse of, let's say, like 2 over 5. Okay. That's how I would write cosine inverse. They're not the same function. It's not the same, doing the same thing. Raising something to the power -1 is doing an exponent to it. When you have cosine inverse, that's the inverse function. That's a reflection in the xy axis. Sorry, the line y equals x. So that's different. Anyway, what's cosine 30? So what's secant 30? Yeah, we got 2 over root 3 here. Cool. Now that's going to be a number slightly bigger than 1, but smaller than 2. Okay, so that'd be 2 over root 3. Cool. Now, guess what? Cotangent is the reciprocal of tangent. So that's cotangent is adjacent over opposite instead of tangent is opposite over adjacent. Pretty straightforward. Yeah, so you can, maybe you have this key on your calculator, the 1 over x key, or you have this key on your calculator. Either one will give you inverse ratios. Now, I'm not particularly interested in this problem here, but you could try it. If you have some trouble remembering, wait, cotangent, that goes with tangent. That one's pretty easy to remember. Cotangent and tangent, all right, because they both have the word tangent in them. But then cosecant goes with sine, and secant goes with cosine. How are we going to remember these? Josh?
Well, you can remember it like what cos with cos can, cos can.
Yeah. Yeah, so if I have like my sine theta, I'm going to write them down here. Sine, cosine, and tangent. Clearly tangent goes with, let's have a different color, cotan. And that's just written down like cotan. And so in each one of these pairs, we expect to see one co. So sine has to go with cosecant, because there's your co. There's one co in each pair. Cosine already has the co, so we don't need a co over here. We just have secant, and it's written down secant like that. So there's a co in each one of the pairs. Cosine already has its co, so it goes with secant. Cosecant goes with sine, because sine doesn't have a co yet. That's how I remember them. There's a co in each pair. Okay? So we just learned 3 whole new trigonometric ratios. Let's take a look at some problem types that you might be asked by fiendish math teachers. We might ask you to find all 6 trigonometric ratios for angles that look like this. So let's try this one. First of all, we can put down a point and label a point. If you want to put this on like the back of your unit circle thing, like in and around, I know you have a note for these triangles already. Maybe you can fit it in there, I don't know. Or fit it on a blank piece of paper. I don't know. This is just these are just examples. So here I want to find the 6 trigonometric ratios for this angle here, and hey, let's find the angle itself as well. Let's call it theta. Okay, this down here is the point 12, -5. And so that gives me the x and the y values, which are related to cosine and sine, respectively. And let's find the length of that arm. Oh, that triangle showed up in this problem over here. Does anyone remember what the hypotenuse is for a right-angled triangle with sides 5 and 12? 13. Yeah, this one is 13. So it's useful to have these memorized if you're going to do a lot of things like math contests and stuff. It's probably not something that's useful to memorize if you're just looking to like find the best investment opportunity or something. But if this is 5 and this is 12, then this side is 13. Because 12 squared is 144, 5 squared is 25. I add 144 to 25 and get 169. That happens to be 13 squared. Okay. So this is Pythagorean triple. All right, so now we've got the hypotenuse, the opposite, and the adjacent. But it's useful to think of this as -5, that y value there. And so then we can write, well, sine of theta is going to be equal to -5 over 13. Cosine theta is going to be equal to +12 over 13. And tan theta is equal to -5 over -12. Sorry, -5 over +12. So we just use our opposites and our adjacents and our hypotenuses and put them in the right place according to SOHCAHTOA. You can also think of this as cosine theta and sine theta, but in these cases I have to divide by h to get like these to divide by h to give me these. That's kind of not right what I just wrote, but I don't want to think about it. All right, and then how about these reciprocal ones? Well, you can just write them down this way. Sine theta. Wait, which one goes with sine theta? Is it secant, cosecant, or cotan? How do you know it's cosecant? Yeah, because we need a co here. So yeah, that's how I remember it too. CSC theta is going to be equal to, how would I find that really easily if I already knew sine? What's cosecant theta in this case? Sure. You could say 13 over -5, or I would probably float this -13 to the top because that's equivalent. But yeah, you just flip it. Just flip the number. And then how about secant? I guess secant goes with cosine, right? And that would be 13 over 12. We just flip it. And then cotan. Cot? Yeah, cotan. negative 12 over 5. Oops, that's a 15. Strange what my hand does when my mouth is moving. So there we go. There's our 6 primary trigonometric ratios for that angle. Let's find the angle. Let's try using, I bet if we use cosine, we won't get it. Let's try cosine. Okay, if we did tangent, and I think, and sine, we would get the exact angle it would tell us.
When you flip the fraction over, like
Yep.
when negative 5 over 12,
Mm-hmm.
the negative stays in the same position.
It doesn't matter where I put the negative, just so long as there's only one.
Okay.
So, and my general habit is to float negatives to the top of a fraction. I find a negative denominator ugly. So I always, if I have a negative denominator and a negative numerator, those would cancel. Like negative 3 divided by negative 5 is just 3 over 5. But if I have 3 over negative 5, is equivalent to negative 3 over 5. It doesn't matter where I write the negative, and I tend to write it as part of the numerator. I think a couple days ago I was not doing that to try and help you avoid confusion, but I just can't bring myself to keep doing it. It's against my instincts. What was I doing? Oh, right, yes, calculating the angle. So if we used cosine here, and we said, okay, I've got 12, and I divide it by 13, and I get this number, and that's kind of a gross number, and then I say, give me the second function of cosine, it tells me this angle is 22.6 degrees. So let's go with 23 degrees. Let's round to 1 degree. And then I look at my visualization, and I say, there ain't no way that angle there is 23 degrees. Okay, that would be an angle 23 degrees, and it would go out, and it would hit this point. Oh, I could have shown that point. That would have been cool. That would have been nice. Up here, and it would have hit that point, right? That point up there would go through 12, positive 5. Huh. And then maybe you're a little annoyed. And then you're like, well, I can see that this angle is just a reflection in the x-axis. It's just down there. I have to reflect down there. So this is actually, if I use 360 minus 23 degrees, then I will find it. You see, it's given me the acute reference angle when I used cosine. So the correct answer would be 360 degrees minus 23 gives us equals 337 degrees. There, circle it. That's theta. Let's try if we used sine or tangent here. These will give us the angle. So if I have 5 divided by 12, that equals that, but it's negative. Okay, and then I do trigonometry. Find me the inverse tan of that. Oh, there it is, negative 23 degrees. Okay, so there it told me the right angle. But it gave it to me as a negative angle, and I want to express it as a positive angle, so I still need to do 360 minus that. Well, 360 plus that, because it's negative. Okay, keep going. Found the angle, found all the things. That was easy, right? Let's keep going. Oh, this one's in the third quadrant. So we have C, A, S. I bet only tangent is positive down here because this point down here is the point negative 15, negative 8. And let's find this angle that rotates this way to create that angle. Oscar?
You should probably know this, but what do you mean when you say like only tangent is positive?
Oh, tangent will be positive and cotan, I guess now. Cotan would be positive and tangent would be positive, but sine and cosine will both be negative for this angle.
So like, if we find like an angle with sine, then it'd be negative?
We're going to expect that the sine of this angle is negative? Yeah.
Oh, okay.
Okay. We've got a triangle with sides 8 and 15. What's the hypotenuse? Just like, boom, all the calculators come out at once, and everyone's like, wow, it's an integer. You did it again. No? No? People aren't doing that? This is how we would do it. We would go 8 squared plus 15 squared equals 289. And if we don't recognize it, we take the square root of it. Oh, it's an integer. Wow. How'd you do that again? I just have a couple of these memorized. Not a big deal. Not a big deal. So the hypotenuse is here 17 long. And now we can write down our primary trigonometric ratios for this angle beta. Still drawing the angle? Oh, yeah. You must be trying to draw it nicely. So here we go. Sine beta, cosine beta. I'm going to zoom out a little bit to lift that up. I have a very big diagram, probably bigger than I need, or that anyone needs. And tan beta. And those are going to equal something, each one. And then let's write down our cosecant, right. I have to actually kind of figure it out each time. I don't memorize these. Secant. And cotan. And we'll find this angle. It's going to be tricky to find because it's in the third quadrant and none of the trigonometric ratios. Like there's no way to trick my calculator into telling me that. I just have to use my acute reference angle. The related acute angle. Yeah. The reference angle. The related acute angle. All right, let's go. So sine theta. So I take the, which one is it? The x or the y that goes with sine? The y goes with sine, right? And we can think about that because it's like it reminds us of the opposite side, even though this isn't really a triangle, but it's the y value is goes with sine. So we have -8 over 17 for sine. How about cosine? What will cosine be? -15 over 17. Good. And how about tan theta or tan beta? What was that? 8 over 15, yes. And how did you know that it wasn't -8 over -15? Yeah, sure. And we can also use our cast rule. So we expect it to be positive, so it's positive. Yeah. But I like your thinking better because you're thinking. You're not just applying the rule without thinking. That's good. Now, how are we going to find cosecant beta? How in the world will we do that? We just flip our sign. You just flip the sign. So it's -17 over 8. Or if you write down 17 over -8, you're not wrong. Oh, there's worse things than that on your test papers. And then cotan beta. 15 over 8, good. One thing I notice about this angle is that sine beta is pretty darn close to -1/2. So I bet this is really close to a 30-degree reference angle. That's how I'm doing my guessing here. I'm always doing these little guessing things before I go to my calculator so that I can verify the output of my calculator. Let's find the measure of angle beta. So if we use, doesn't matter which one we use, let's try tan. Tan's going to be the easiest. 8 divided by 15 equals that number. And then I do trigonometry, and I take the inverse tan of that number, and it tells me, oh, right, I was expecting something really close to 30 degrees, and I got 28 degrees. That is really close to 30 degrees. So what that's telling us, how will we find the measure of angle beta when this is stubbornly not telling us an angle in the third quadrant, but instead, oh, look, 28 degrees would be just if I continued that line that way. It would be that angle. How am I going to find this angle beta? You just do 180 plus 28. Yeah, that's it. So we can find this here. That would be 28 degrees. And this would be plus 180. And then we would have it. 28 plus 180. So it's 208 degrees. Beta equals 208 degrees. So this is the new material for today, along with some review. I will bring my whiteboards and come visit as many of you as I can. Any questions, hit me up by email. Oh, and homework problems for today. What's that? Oh, right. Yeah, so let's take a look at the unit circle. The unit circle is something that you can fill in. I have a handout of it. Let me open it. So it is here, unit circle. So the unit circle, this is for your reference, and you can fill this in with all the different values of the unit circle. So what you can do is go through and say, this is a 30-degree angle here. You need a pen. A 30-degree angle. This is a 45-degree angle. And this is a 60-degree angle. This one up here is the 90-degree angle, the right angle. This is a 0-degree angle. This would be negative 30 or 330. I would write it down with a positive angle. This is 360 minus 45, so that's 315, a barbell with 3 plates, which I have no business talking about lately. And this one over here is 225. This one over here is 135. You know, you get all the different angles on, do your 30s and your 60s there. And then you can get the exact value of the different trigonometric ratios on there as points around the unit circle. One way you could investigate these is on Desmos. I would not recommend this method, but you could use this method. You would go into Desmos and you'll find that below all of your saved graphs, Desmos already comes preloaded with a bunch of saved graphs that you can use for learning purposes. If you go into Trigonometry Unit Circle, they have this nice graph here. Okay, and then you can change the value of that angle. So let's say you wanted to know, what is sine, cosine, tangent for 135? You would advance that to 135, and then you would check that. And oh, darn, it's giving me decimals. So it's not really that useful. But what is useful is to go into your triangles that we looked at yesterday, the special triangles. And if you had the 45-degree triangle, you would remember that this side is 1, and this side is 1 over root 2. This side is 1 over root 2. And that can give you your sine, cosine, tangent. And then, if you're filling in like these other ones, let's say I get this over here. The cosine of 45 degrees is 1 over root 2. The sine of 45 degrees is 1 over root 2. And then I can use just a reflection over here to find this point. That's this point over here is 1 over root 2, 1 over root 2. So it's like about 0.7 or so. 0.707, I think this is much more accurate, 0.71. Anyway, over here, I noticed that the x would be negative, so that would be negative 1 over root 2, and that the y would be positive, so that would be 1 over root 2. Okay. And then I can extend that thinking all the way around in 360 degrees. I can also do a similar thing for my 60-degree triangles and my 30-degree triangles. Say for the 30-degree one, I might visualize this triangle here that goes down to there and comes along there. And then I'm like, well, that hypotenuse is always 1. This side is 1/2, and this side is root 3 over 2. So the x value would be root 3 over 2, and the y value would be 1 over 2. And then I'd reflect it over here at negative root 3 over 2. That's root 3 over 2. And then this is 1 over 2. And then I can apply the same thinking to my 60-degree triangle and my 120-degree, and also figure out this 90-degree thing. Oh, that's 1 high. So that's a 0 in the x and 1 in the y for 90 degrees. And blah, blah, blah. Fill in the whole thing. Get that done today. And you're going to want to do some practice today. The practice problems for today that are recommended are these ones. Oh, don't worry about quiz. I'm not going to look at that. I probably don't want to quiz you on Monday. Okay, so here's the assigned work for today. I'm going to freeze the screen so you can see it there. And then say goodbye to all of you at Team Learn at Home. Bye for now.